Good afternoon, children. How are you all? I hope you are fine. I am very glad to meet through this class. Are you enjoying the quarantine period? You are enjoying more, yes? Are you eating healthy food? Are you obeying your parents? Each and every one of every one of you are obeying your parents, yes? Very good children. Okay. Now we will see the lesson 1. Everybody take page number 5. Look at this slide also. Take page number 5. Look at this slide. This lesson name is matter. This lesson name is matter. Now, what is matter? First of all, we must know what is matter. Matter is defined as anything that occupies space. For example, you take book or you take any other thing if it takes space or if it has mass or it may be perceived by our senses, that is matter. That is matter. Did you understand or not? Got it? About matter? Okay, you got it. Now, heat, light, electricity and sound. Heat, light, electricity and sound are not matter. Why they are not matter? Why they are not matter? But they are not matter, but they have capacity to do work. They have capacity to do work. For example, heat. You take heat, they can boil water. It helps to, it uses to boil water. Then plants prepare their food with the help of light. With the help of light. Already we know plants are preparing their own food. Plants are preparing their own food using the light. They are preparing their own food. Next, electricity. Electricity makes the fan revolve. Not only makes the fan revolve. It helps to every day in our life. It helps to every day in our life also. And sound causes the eardrum to vibrate. Eardrum to vibrate. The heat, light, etc. They are the forms of energy. They are heat energy, light energy, chemical energy, wind energy. So they are forms of energy. They are forms of energy. The capacity of doing work. The capacity of doing work is called energy. The capacity of doing work is called energy. What is energy? The capacity of doing work is called energy. Next, states of matter. States of matter. On the basis of physical properties, matter can be classified into 3 states. Matter can be classified into 3 states: solids, liquids, and gases. Solids, liquids, and gases. Note this point. If it is an extremely high temperature, the 4th state can exist. That state name is plasma. That state name is plasma. And also at very low temperature, a 5th state can also exist. That is called Bose-Einstein condensate or Bose-Einstein state. This is a 5th state. This is fifth state of matter. This is a fifth state of matter. Chemically, matter can be classified into three categories. Matter can be classified into three categories: elements, compounds, and mixtures. Elements, compounds, and mixtures. First of all, we see kinetic molecular theory of matter. Kinetic molecular theory of matter. Kinetic molecular theory of matter is a concept that basically states that atoms என்றால் அணுக்கள், molecules என்றால் மூலக்கூறுகள். So states that atoms and molecules possesses an energy of motion. Possesses an energy of motion. That is kinetic energy. That is kinetic energy. It perceive as temperature. That we perceive as temperature. What is kinetic energy? Why ma'am is telling kinetic energy, kinetic energy? What is kinetic energy? It is produced by movement. ஒரு இயக்கத்தினால் உருவாக்கப்படுகிற ஒரு ஆற்றல். இயக்கத்தின் மூலமாக இயக்கத்தினால் உண்டாகக்கூடிய ஒரு ஆற்றல். That is kinetic energy. In other words, atoms and molecules are constantly in motion, and we measure the energy of these movements as the temperature of the substance, This means if there is an increase in temperature, suppose if the temperature is increased, or the temperature is increasing, the atoms and molecules are giving more energy, or we will gain more energy when the temperature is increasing or increasing in temperature. We will gain more energy. That is kinetic energy. And they move even faster also. Very faster. They move even faster. Next, kinetic molecular theory states that. First point, look at the first point, children. Page number 6. Look at this first point. All matter is made up of tiny particles. Very tiny. What is the meaning of tiny? That is very, very small particles. That particle name is atom. That particle name is atom. When the atoms are joined with one another, it makes, or it gives molecules. All matter is made up of tiny particles, that is called atoms. When these tiny particles or atoms are joined, they form molecules. Next, these particles are in a constant motion. What is constant motion? What is constant? Constant is unchangeable. The particles are in a unchangeable motion. The third point, molecular motion is random. Particles are in constant motion. In this kinetic molecular theory states that the matter particles are in a constant motion, but the molecular motion is random. What is random? What is the Tamil meaning of random? The motion done without any method. Next, Fourth point, look at the fourth point. Particles in motion possesses kinetic energy. Particles in motion possesses kinetic energy. Kinetic energy. Kinetic energy. This energy produced by movement. This energy, kinetic energy, kinetic energy is produced by movement. So particles in motion possesses kinetic energy. Fifth point, there is an exchange of energy. There is an exchange of energy between the molecules. When it is happening? During a collision between them. When the collision between the particles, their exchange of energy forms. Their exchange of energy forms. This exchange of energy, where it forms, when the particles during a collision between the particles, during a collision happens between the particles. Next, particles in gases do not exert large forces on each other. Particles in gases do not exert large forces on each other unless they are in collision with each other. Unless they are in collision with each other. Next, collisions between these particles are perfectly elastic. Perfectly elastic. The molecular motion is greatest in gases. Molecular motion is highest or greatest in gaseous matter, but less in liquids, and also very least in solids. You see, look at the difference. Look at this point, children. Look at this point. How many differences are here? Molecular motion is greatest in gases. Molecular motion is greatest in gases, but less in liquids, and very least in solids. Very least in solids. Solids retain a fixed volume and shape as particles are tightly packed. Solid always retain their fixed volume and also shape, because the particles are tightly closed or tightly packed. Tightly closed or tightly packed. Usually in regular pattern. Next, liquid. You take liquid. Liquid assumes the shape of the container. Liquids assumes the shape of the container which it occupies. The shape of the what is the shape of the container of the liquid? That is liquid shape. That is liquid shape. You take, for example, you take different container. You should not take same container. You should take different container. You pour water to the container using beaker. You pour water to the container. At last, you can see the shape. You can see the shape of the container. You can see the shape of the container. So this liquid assumes the shape of the container, but maintains its volume. Maintain its volume. For example, you take water in a conical flask or measuring jar. You add some crystals, for example, sugar or salt. Stir it well, mix it well. At last, the volume will not be changed. The volume of water will not be changed. That is maintaining its volume. Okay, the next last point, gases. Gases assume the shape and volume of their containers and will expand to fill container of any size, and also they will expand to fill container of any size, fill containers of any size. Nowadays we are using LPG, liquefied petroleum gas. So the gases assume the shape and volume of their containers and will expand to fill container of any size. They can fill any container. They can fill the container. The gases only can fill container of any size of container. Gases can fill. Next, all matter is composed of particles. All matter is composed of particles which have intermolecular spaces. Which have intermolecular spaces between them. Which have intermolecular spaces between them. So they have matter is composed of this. If they have intermolecular spaces between them, that is matter. That is matter. Next, the next one, which attract each other with force. If the matter attracts each other with force, that is all matter. That is all matter. Then they are in a continuous random motion. They are in a continuous random motion. Already I told you about random. Random motion has done without method. Random motion has done without method. Okay, children. Still now we are studying about matter. What are the states of matter? Kinetic molecular theory of matter. Kinetic what molecular theory states that what kinetic molecular theory states that. So 11 points are given in that. So we studied that. Next, change of state of matter. Change of state of matter. Change. Already we know matter existing in 3 states: solid, liquid and gases. So change of state of matter. The matter states are changing. Matter states are changing. They may change from one state to another. The states are solids, liquids and gases. They may change from one state to another state on change in temperature or pressure. Change in temperature or pressure. Then only the matter state can change. Matter states can change. The states from they can change from one state to another state. They can change from one state to another state during temperature or pressure. During temperature or pressure. This change is termed as change of state of matter. Change of state of matter. Change of state of matter. Next, you look at this, children. ICE, ice, that is ice, solid. When this ice at 0 degrees Celsius, at 0 degrees Celsius, that is in temperature, that's why the one state change into another state. So when we keep the ice at 0 degrees Celsius, we will get water. We will get water. Next, water, that is liquid. That is liquid. Now, when the water at 100 degrees Celsius, when water at 100 degrees Celsius, we will get gaseous state. That is steam. That is steam. Steam into channel neeravi. So ice at 0 degrees Celsius, it changes into water. Then when the water in a liquid state at 100 degrees Celsius, this state changes into steam. Changes into steam. So this is change of state of matter. Change of state of matter. Next, chemistry in our lives. Chemistry in our lives. The earth, already you must know these 2 points. You must know the earth is one large mixture of gases, liquids and solids. The earth is one large mixture of gases. Gases are present in the earth. Not only gases, liquids also present in the earth, and solids also present in the earth. So the earth is a large mixture of gases, liquids and solids. Gases, liquids and solids. The next point must know this. The state of matter changes as you add more energy. As you add more energy. Next, interconversion of states of matter. Interconversion of states of matter. The heading is not there. So listen, page number 6. You take page number 6. Interconversion of states of matter. Interconversion of states of matter. The phenomenon of changes from one state of matter to another, and then back to the original state. Then back to the original state. This is called interconversion of states of matter. Listen children, listen carefully. Change from one state to another. Change of matter from one state to another, and also at last and next, and then back to the original state also, and then back to the original state. So that is called interconversion of states of matter. Conversion of states of matter. Now, how the matter can be changed? How can matter be changed? How can matter be changed? Matter can be changed from one state to another. How matter can be changed? First of all, by changing the temperature. By changing the temperature. If the temperature changes, the matter can be changed from one state to another. The matter can be changed from one state to another. Second point, increasing or decreasing pressure. If they change from one state to another, the second reason is increasing or decreasing pressure. Increasing or decreasing pressure. If the pressure is increasing or if the pressure is decreasing, the state of matter changes from one state to another. The matter can be changed from one state to another. Next, changing both temperature and pressure. The third one, the matter can be changed from one state to another by when changing both temperature and pressure. When changing from both temperature and pressure. Okay, children. Next slide. We will see the next slide. Are you listening me, children? If you have any doubt, you listen to this carefully, and you should read the book 1 or 2 times. You should read the book 1 or 2 times. You can understand. What is this passage? What is this passage tells us? You can understand easily. It is the online class, so you cannot ask doubt directly. Yes. So I am feeling unhappy. But if you read the book 1 or 2 times, you can understand very easily. First, you listen the class carefully. Through this class, you can understand first. Suppose you can't, you should read. Then you can understand. Okay, children? Now, reading book is improving your knowledge, is improving your ideas. Reading books gives you more ideas, and reading books is helping you to study. Reading books is helping you to study. Now, interconversion of states of matter. Interconversion of states of matter. You look at this: solid, liquid, gas, then liquid. Solid states into liquid state, that is melting. Then liquid states converts into gaseous states, that is evaporation. That means vaporization method. Then gas converts into liquid, condensation, that is liquefaction. Liquid state converts into solid, that is solidification. They are freezing. That process is freezing. Now solids converts into gas, and gas convert into solid. That is sublimation, deposition. Sublimation, deposition. When the gaseous state changes into solid, that is deposition. When the solid converts into gas, sublimation. Already I told you how the matter can be changed from one state to another by changing the temperature, increasing or decreasing pressure, changing both temperature and also pressure. Temperature and also pressure. Now, you see, interconversion of states of matter. Interconversion of states of matter. When matter is heated, it changes from a solid to a liquid. It changes from a solid to liquid, or from a liquid to gas also. For example, you take ice cube. You take from the freezer. You take out from the freezer. You keep the ice cube for a long time. It starts heating. So that ice cube, now the ice cube is a solid. After heating, it becomes liquid. Now you take water. When we heat the water, from the water, that steam comes out. The steam comes out. That is gas. So when the matter is heated, it changes from a solid to liquid, or from a liquid to gas. These two will happen. The reverse process also will happen. When they are on cooling, the reverse process will happen. Next, on decreasing the pressure. First temperature we saw in this first paragraph tells us when it is heated or when on cooling these changes will happen. Now when they are on decreasing the pressure, when the pressure are decreasing, a liquid evaporates. A liquid evaporates. That means changes into its gaseous form. Changes in the liquids evaporate. So that liquid changes into its gaseous form. Next, on increasing the pressure. When on increasing the pressure, or when the pressure is increasing, in that gaseous states, a gas liquefies. In that gaseous states, changes into liquefies. That is, changes to its liquid state. That is interconversion of states of matter. Okay, children. This today we saw up to this. So you have learnt matter. What is matter? What are the states of matter? What about kinetic molecular theory of matter? What says the kinetic molecular theory states? Kinetic molecular theory says that what are the points we have seen. The next we have seen the change of state of matter. Then interconversion states of matter also we studied. I am not giving homework today. Next class I will come and meet you with classwork, homework, and also the remaining lessons. So you children, you should read this book. You should read this book. After that, I will give when I give the homework, you can make the question easily. You can answer the question. Very easily. Okay, children. Now I am giving some information. You should obey your parents. This is quarantine period. You should not go out of home. If you go out of home, many friends, your friends are gathering in one place. So how the coronavirus affect the children while sneezing time and also coughing? Yes. So when you are not playing with your friends, you are protecting yourself. Yes, you are protecting yourself. So you should not go out of home. You must protect yourself. So read the book and also obey your parents. Eat healthy food, children. Eat healthy food. It gives more energy and it helps you to protect from the diseases. Okay, children. Today class, I will finish today class. And the next class, I will meet you. Okay, children.